The last term we will describe in this section is called an R permutation. And what's an R permutation? It's basically when you permute R elements out of N. So kind of like if I had the word computer, but I only decided to play with the letters C, O, and M. So if I wanted to just mess around with those letters and reorder them, that would be called an R permutation, where R stands for how many elements you're choosing out of the original N elements. Okay, the formula is pretty much described right here, but you don't have to use the formula to get the answer. You can always calculate it by using logic, but having the formula will help you a little bit because then you can plug in the calculator. So let's describe how the formula works with the first example, P52. Sometimes this is known as 5p2, like that also. Okay, another way of computing it is to use a calculator. So the calculator would usually ask you to plug in 5p2. This is normally found in the probability menu under math. But anyway, if I'm doing it by hand, the rule is whatever first number you've got, that's going to be called n. And whatever second letter you've got, or whatever second number you've got, that's going to be called the R. Okay, so n and R. And supposedly, I should be putting 5 factorial in the numerator. That's what the formula says. And then divided by n minus R, which is basically 5 minus 2 in the denominator, and then factorial. Okay, that's what my rule basically tells me to do. 5 on top, 5 on the bottom, and then subtract the 2 because that's the R. And so in other terms, this is going to be 5 factorial divided by 3 factorial, which is at the end at 20. Okay. Now let's try to understand why this is happening. Okay. So what is it that we just calculated when we say 5, comma 2? Basically, we have 5 elements, A, B, C, D, E, let's say, and I'm choosing 2 of them at a time. So I'm choosing A and C, for example, and I'm reorganizing it. Or I'm choosing B and D, or I'm choosing B and E, or so on and so forth. So basically, every time I'm making a 2-letter word, so how many choices do I have for the first letter? Well, I have the choice A, B, C, D, or E. So there are 5 different ways of choosing that first letter. Let's say I picked B, then how many choices do I have available for the second letter? Well, I could choose A or C or D or E. I can no longer choose B itself because I already chose it, and this is a permutation. Repeats are not allowed. So let's say I plug in E here. Well, how many choices did we have for that? We only had 4 choices, 4 different ways. And using the multiplication rule, 5 times 4 is 20, which is the same thing as saying 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1, which is what this formula is basically telling us to do. So that's kind of a simple reason why this works. So I wrote a simple justification here, but you normally don't have to write down the justification. So if I tell you calculate P 5, 2, you just tell me the number is 20. But why does it work? Because we are choosing 2 things out of 5 possible things. That's what this actually means. Okay. So the next question is, how many 4 permutations are there out of 7 objects? So another way of saying this question is to write down P 7, 4. So this is how many choices are available. The total is 7 things are available, and I'm choosing 4 of them. Okay. So according to the formula, it's supposed to be 7 factorial divided by 7 minus 4, the whole thing factorial. Okay. So 7 because that's the n, and 4 because that's the r basically. And so this is 7 factorial divided by 3 factorial, and a calculator will give us the answer, which is 840.